So welcome also from my side this afternoon. We will once more look into the subject of Industry 4.0 and IoT or IIoT, Industrial Internet of Things. Actually, we are not linked to that as we are specialists of handling parts, but we have invented a solution which connects our grippers and devices, as you can see them here with the laser there, which connects our devices directly to our cell phone, for instance. And this is what I'm going to introduce and talk about. I will quickly go through to explain you who we are and what we do and what that has to do with Industry 4.0. Just going quickly through. We are a German-based company located in the Black Forest, founded 1910. With first generation, they made razor blades, and 1945, after the Second World War, the second generation reinvented the company, and they started to make trailers, etc., for aircraft, etc. And there you see the small building in the Black Forest. Since 1984, we have a CEO, second generation, Dr. Kurzschmalz, and the second brother joined the company, and nowadays we are roughly 1,000 employees running a worldwide business. All over, let's say 80% is export. So our market is in US, it's in China, in Japan, etc., elsewhere. I will go through quick because we will look into the technical topics more detailed later on. What is our core business actually? And this is similar of what Charlie will talk about. We are experts in gripping parts from the surface. And we start to use vacuum at the very first step, but then even we have magnets, we have adhesion grippers, etc. All kind of forces we use to grip parts from the surface, and we start from the component itself. There are suction cups or grippers, magnets, etc., sensors, pumps, up to a complete system, which is then a complete end effector. So what we do is we do automation, but our expertise is the end effector itself. And this, for instance, is an example where we have cutouts. We take cutouts from a cutting machine. We've seen this morning already from Charlie, how these machines look like, and we are building the end effectors. We are taking all the parts from the table. And here you see some other examples. Even so, we build complete handling devices for windmill and industry. You see here, this is a blade of a windmill, roughly 60 meters long device. Even so, we're directly looking into the processing of material, like composite material here. To fix it and to clamp it and to hold it the workpiece during the operation. So these are some examples of these kind of grippers. We do the complete design, including the control here. So we connect these grippers. We have the intelligence of these devices we have mounted either on the robot hand or the robot itself up here, depending on how it looks like. And further on, we also are looking into complete layer-wise gripping or independent gripping, where we have a large area gripper which is gripping the part independently from the surfaces, how it looks like, if it is round or whatever. So all these kind of things is our core competence. Also very sensitive parts. We are handling semiconductors. We are handling hot parts or very weak or whatever is fragile parts we also handle. And so we are in a broad market. We are not sticking to any specific branch, but the most important for us is automotive. Also what we do is we are providing complete handling devices. This is the so-called tube lifter, which is with the vacuum system gripping parts to, for instance here, plain wood, whatever, or sheet metal, all these kind of parts. Or we also provide gripping systems for windows and in all aspects. Even so, we are providing assistance systems for handicapped people. And this is not giving the presentation, and we call this so-called exoskeleton developments. We are also deeply involved, and this is why the sensor topics is so interesting for us. Because as you can see here, for instance, this is a handling device where there's a sensor integrated, and this sensor is following automatically, like a rope lifting device, the movement of the worker. But that's not, we do a lot more. I just made a broad overview, a very small, limited overview of what we do. The core topic I would like to talk about is different. I would like to talk about the difference is what we do is we have components, we have solutions, but we also have the process itself. And the differentiation, what we do is we're not looking in the efficiency of the device itself. This is a vacuum pump, by the way. We also look into the production process, and we interlink them to each other to increase the efficiency of the entire process. And this is how Industry 4.0 gets into the game. So we have the energy efficiency we do on the side of the intelligence of the device, even so of the performance of the ejector. This is a Venturi nozzle integrated in this pump, but we are running an integrated energy and process control module. The way it works is we have a gripper device here, and in this gripper device we have different kind of conditions. In the first ramp-up setup of this gripper, the condition might be perfect, that the line is running on full speed. But then it could happen that we have somehow an interruption, or we have a clogged silencer, or we have whatever, a leakage in the system, and this is a situation we want to detect preventively before we have a breakdown. So what we do is we have integrated an intelligence in these devices, and this intelligence is communicated to a PLC or to a line PC, so-called. And then all of a sudden we have a closed circuit that we give a signal, said, hey, we have an issue here, and you should make a maintenance stop, maybe whenever it's necessary, next week, next month, next day, or even today, depending on the condition. And we call this preventive maintenance. So we communicate back and forward with the line PLC, and this has nothing to do with the SPS. This is going to the computer. So we are aggregating a lot of data in our grippers, which are used on an upper level, on a higher level. So the communication channel we use, we have heard that from SIG this morning, is IO-Link as well. IO-Link is a consortium which is founded in Germany, and this IO-Link consortium is taking care that the communication standard is all over the same. So we have the same protocol using as SIG or others, or Baluf or Siemens or all these German companies known, or European already. We're having the same channel. So at least this channel is somehow organized in a way, right? So and we use a bidirectional communication to a higher level, how to say. So what we do with that is, as I already explained, is we do condition monitoring. So we see the system availability, we see the values, and we see how if there, for instance, if there's a leakage inside, we detect faults before we have a breakdown. So we just ongoing detect the condition, and we communicate this to the upper level. On the same way, we do energy monitoring. So we are detecting whether there's a failure, that the energy consumption is getting up. And this is all in the aspect of being as efficient as possible to reduce the energy consumption for these gripping processes. We have, as I mentioned before, an IO-Link interface, which is plug and work. So we just disconnect our devices and connect another one onto it. And we don't have to make any setup anymore. We don't have press any buttons, nothing. This is all gone. This is all automatically given in the device, as well as that we are having an automated air saving function. Reduce, as I said before, the energy consumption as much as possible. So how it looks like is at the end, our customers, this is a picture which is taken from I think, Volkswagen press shop plant in South America. Which is controlling the energy consumption of a press line, and it's running continuously, and our devices are sending these signals how much energy is used for each cycle. And this is just an example we have taken out, when the energy consumption is getting up, we detect that, and we inform the operator that we are getting to a certain level, and then we have some threshold values as well given, so we detect if we are getting across that line, you could have a breakdown. And you can imagine that the press line is an investment of, I would say, something between $50,000 and $70,000, million dollar. And you can imagine that 1 minute of breakdown is a huge cost they have, because it's a loss of production. And this is where we're actually looking into, and this is what we want to avoid. Therefore, I have a video brought with me to give you an explanation, but I think it's not working because... Oh, now I have to get back to the path. Sorry, where was the hyperlink does not work, so I have to go into the folder to switch it on directly. Can you tell me where it is located? Or? I'm sorry. It's okay. Because when you copy from the memory stick on the computer, the hyperlinks are getting lost. Yes. Okay. So this is just one example of what we do. This is a video out of a press line to give you an impression of what is all behind. This is a press automation, a press shop at a well-known branded company in Germany called Audi. And you see a press line here. You see in the sheet metal parts which are coming out of the line. And our core business is we provide these gripping devices, including the vacuum generators and the suction pads and the sensors, etc. And it's a huge investment, and these are small parts we provide, but you can imagine that if one of these suction pads fails inside, whatever happens, you see a lot of these pads here. So we supply the entire gripper. The entire line is down. So what we do is we detect each and every suction pad, each and every vacuum device with our intelligent ejectors, and communicate to the PLC, to the line PLC, and forecast whether they will have a breakdown or not. Even so, we detect whether there's something in these gripper devices which have to be maintained, and we also inform the operators that it does not have to be maintained. So even we save time for the service people, because the detection where a service is necessary or not is taking place automatically. This is all given, and this is already, we do this since 7 years, and this is Industry 4.0 purely. And all of a sudden the Industry 4.0 name crossed by, and we say, wondering what is this? We already do that. And the question is how to connect that. So this is how it looks like, just to give you an idea, an impression.
I can ask actually, the main source of failure is because the weather itself, or because of some leakage? Or?
Well, in these press lines, there are a bigger number of possible failures for sure. I mean, even in the presses, etc., all this environment clear. But we know that roughly 30% of the failures are dedicated to issues in the vacuum system. So we reduce the breakdown. So I close that again. Go back to my presentation. So this is finally what we do in this press line. We detect these failures and communicate them to an upper level. So what makes the difference? The difference is the performance of the product itself, certainly, but also the intelligence. And this is what we heard this morning. Making intelligent sensors is something which will help us to implement this industrial Internet of Things and Industry 4.0. It's a necessity, and it's the only way to get through it. And we have to communicate and inform about the ongoing conditions we have in our operations. And this is why we need you guys from the other side to connect us to the world, to the upper world. And this is something we have to interlink. But seriously, it's necessary to do so. So making the process itself visible and usable in the production, so use these informations, and this is already Industry 4.0. Even further on, we might have a close look to what Industry 4.0 means, and we heard about this morning. It is the saying is we have somehow a condition here, and we detect informations here which are giving in our smart field devices. And what we want to achieve is that our production becomes highly flexible and highly productive and resource efficient. And we want to individualize these devices that they are self-adjusting. And we want to decrease the complexity. And this is what we also have seen, is we are connecting our devices just via IO-Link, and all parameters are automatically set. So we don't have to make any programming. So for us, from our point of view, Industry 4.0 will help us to make automation easier. And of course, autonomous production units organize themselves. So what we do is already, if there's something coming up, this device is informing the device on the other side that there's an issue going on, and then they adjust themselves. The difference is what we do is we are not using only sensors. This is also an actor. So because this is a pump. So we use IO-Link to operate it and to measure in the same way. A very intelligent device. And as it is mentioned here, the employees should benefit from this intelligent assistance as they are self-adjusting and self-healing, how to say. The communication structure we are looking into in the normal world today is, we have seen a similar picture from SIG this morning, is that you have the ERP, SAP, whatever is here. Up there we have MES, manufacturing execution systems, we have HMI interfaces, surfaces on the PLC, etc. Then we have the SPS, or the robot controller itself, and the robot controller is then controlling the field devices here, the sensors and the actors. And the same picture as SIG, more or less the same. The problem here is that whatever communication and data we detect, we cannot communicate through all these channels because they are not used to it, to handle these data. So the Industry 4.0 is looking different in a way that all of a sudden these devices are in between somewhere, and we have only one channel which is real time. So here the robot controls the pump and said, okay, you have to switch it on, you have to pick up the part, you have to release the part, you have to adjust the value, whatever is needed is going through the robot. But all other data are then going in different ways. And this is something we have to differentiate, and this is where we right now are in a phase, and a discussion is going on in the market. How could we get our smart field devices we already have into this world, attached to the system, to the upper system? And we have no clear answer at the moment. So, the way it looks today is, and these are some examples of devices we are providing. We have this kind of pumps. We have electrical driven grippers, which are electrical generating vacuum and applying force to a part, and which are highly energy efficient. We are controlling motors. We are having intelligent grippers, which are able to detect and to grip different kind of sizes independently, how big they are and what is the shape. We have data storage. We have vacuum sensors and terminals. We have electrical needle grippers for all kind of fabric handling, for instance. And the situation is, as we mentioned before, is right now this is running through a field bus into the PLC. What we have to achieve is that we're using these data into the cloud, because this is the cloud on the right hand side, and this has nothing to do with this field bus. And this is a solution we already provide, and the way we provide I will present you now. We connect the world from the industry directly to the cloud without using any cable anymore, and I will show you how this works. I hope I find my thing. This is a new sensor. This is operated via IO link, so it's everything what's going on in here is absolutely visible. But even further on, there's an NFC tag inside, which is directly linked to the controller inside. And if I get close to this switch, first I have to make sure that I'm connected to the internet. But if I usually, hopefully it works, if I get close to the switch, I'm forcing a signal. And all of a sudden, you can see I'm directly connected to the device. And this is not power, this is power off. There's no energy inside. So all of a sudden, I'm directly linked to the cloud, and I have all data which are set. I have the setting inside. I have everything information I have inside. Control, whatever, is getting all the device into the cloud. And this is connected to our server, which is based in our company. And all of a sudden, I can see if there's a failure inside, I have a real text here. I say, hey, I have a failure. This is the reason, and this is how I fix it. So the benefit out of this connection is huge. And this is the first real step to link the industry to Industry 4.0, right?
So there is no power whatsoever in this sensor?
No, I don't need power for that.
No, battery.
What? No, it's no battery, there's nothing.
Nothing.
No.
Okay.
So the reason we use NFC is that we have to make this physical step to the device, because we have a lot of, in our machines, we have a lot of these switches. We just go to the switch and take the data out. If you would collect this from a longer distance, you have a huge amount of signals. You have to sort out which I'm talking to. So the way we use it is we're using NFC. The other big advantage is if you need an operation manual for that device, you just force it by that movement, and you can directly, there's an operation manual popping up, and you see I have all descriptions, how to ramp it up, how to make startups, etc. It's all given. And that's the big differentiation of these smart fleet devices we have implemented into the market. So we have some of those. You see here, these are the pumps, and this is the new switch over there. And we can do this with each and every device. We can do these operations. And we do this also with very complicated grippers. I just brought with me some examples. This, for instance, is a gripper which is dedicated to produce, made out of carbon fiber composite material, a pressure cone of a Dreamliner from Boeing. They are taking the fabrics, 2D fabrics, different kind of shapes, and they have then to form it to put it into the dies. Right, this is carbon fiber RTM processing. I have a video with me. I hope that works. Seems good. It's a huge gripper. It's roughly 2.5 meters by 1.5 meters. You can see here what we're doing is we're gripping up the part, and then this gripper is itself forming the part in different shapes. So we can do every shape, every circle, because here we drape this fabric into the die. This is just a quarter of a die. The original part is like a huge thing. That's a pressure cone of the rear of the of an airplane, and this Dreamliner and the Airbus A350. It's made out of composite material, and in this gripper, I may run it once more. What is so specific about it? Let's just stop it somewhere. This gripper is specific because it has 127 servo axes, 127, and it has 180 vacuum generators, which are each individually controlled, because we have 600 different parts we have to take, different shapes, different whatever. And the entire control is integrated in this gripper. So we are using, again, Industry 4.0 devices to have the entire intelligence and the logic how this gripper must be operated, integrated in the gripper. And the gripper itself is roughly 200 kilogram weight. I don't know how much this is in US scales.
450 pounds.
Right, like something like that. And you can imagine that this would not be possible with the regular technology. So what we do is we integrated IO-Link as a master, and we control the entire device by one IO-Link master.
So I think there was a question.
Yes.
Real quick.
Oh, yeah. It says DLR director. It's which one it is? Because DLR, what is the technical? Because that's just a DLR Gripper.
DLR is, this is like the NASA.
I know the German Aerospace Center. We also
Right.
have Gripper from them in Norway, but
Which area?
is it, yeah, the DLR something.
It's the ZLP DLR in Augsburg, which is close to Munich, and this gripper has been made for testing. But we already now this gripper is used at PAG. This is called Premium Aerotech, which is a supplier of Boeing and Airbus. They are making the all carbon fiber composite material, even the flaps, etc. And even the flaps we do with this kind of grippers. So we have these forming grippers which are going in each and every curved surface, right?
Involve the DLR hit hand. It would be a bit different. It's anthropomorphic gripper. That's what I was curious about.
I know all of them, and you know them apparently also. We have done a lot of surveys with the DLR, but that one is already in the market and used in real application. Any further questions? So this gripper is also autonomous, we call it, because it's self-optimizing. It configures itself, and it's also having NFC. So we also are able to operate and program this gripper with a smartphone. Imagine. So when we talk about Industry 4.0, we believe that the key question is how to make the operation simple, and how to make automation easy to control. And what we do with this switch, once more, we have an IO-Link device here. We can connect it directly to the controller, but even so, we can go through NFC, or we have a control device in between. We can plug in between. I do not want to make a promotion of our products here, so I go not too deeply into that. I just want to explain the technology and what is the strategic point of view we have. Right? I'm not in sales. So the way it works is simple. We get close with our smartphone. We force a signal. We send energy to the device. The energy responds to the device. The device then, the cell phone is connected to the internet, and the internet is connected to our server. And this, by the way, could also be an intranet. So, for instance, at Ford, we are discussing with Ford in US in Dearborn. We're discussing this. They certainly want to have their own intranet because the information which are getting out of our devices are critical. We had this discussion this morning. Safety is a big thing because we can detect how often the system fails. We can detect how many parts they have produced. We can detect where this is. Exactly. We can geolocate these devices. All of a sudden, everything is visible. Right? So, and they certainly ask us to limit the information. So it could, for us, we are flexible. We say this could be a Ford or a Daimler or whatever, or Trumpf intranet server. And this is forcing then a mobile app, and this. So we do not need to install any application. You just use your phone. I could use your phone if you have everything but Apple is used. Is working. Apple has locked this function so far.
It's Android.
Android or Nokia, what is it? BlackBerry, and Windows phones are also working well. And the iPhone 6, the next generation, will work as well because it has NFC, and this function will be unlocked anyway. So this is the first channel we opened. The second channel we will open in the future is we rewrite devices. So on the way back, we can program also these devices. Not only a switch, this is a silly switch, it's just detecting pressure and temperature. We also can operate this kind of vacuum pumps. These are Valve. This is a Valve Island, which has up to 16 channels operated by IO-Link, but also NFC. So here we can, let's say, copy and paste the programming from one device to another. Right? Very simple. And the funny thing is, and this is what we realize, is the adjustment is just done. You know, everyone can operate this kind of smartphone. Everyone can do that. If you want to program these devices with buttons, etc., you have to go to a manual, etc. And this is also Industry 4.0. Make it simple, make it easy to use. So what we address is several areas. So we address certainly the commissioning engineer who is running real time. This is Ethernet, whatever based, we don't care. We have every devices with Ethernet available, or Profinet or CAN bus. But even so, we are addressing maintenance engineering, running around with their smart devices, and we also communicate data to the management level where we can detect the conditions and we can forecast whatever happens, energy consumption, etc. This is what we do, and this is how we do that in future. This is a strategic approach, and this is the Industry 4.0 level we are getting into at the moment.
In action, application. Yeah.
Yes. Conclusion? The Internet of Things, or this industrial Internet is the right expression, needs intelligent devices, enable us to communicate, and even so let the machines to communicate, which is our so-called smart feed devices. We have those devices available, as SICK and others do. The differentiation is, from our point of view, that we not only operate sensors, we also have actors. And that differs. So we're using IO-Link Class B.
Actuators, yeah.
Yeah, actuators. We are collecting this process data. We make an interpretation and we communicate them to all levels, whether it's needed. And the real benefit in terms of 4.0 is optimization of the energy consumption, prevention of errors and failures, and increased performance and optimal processes. That's it.
Thank you
very
very
much. Support.
So we have time for a few questions.
And what does that maybe, that flexibility, actually, it's nice. That also raises up the question of process security. And if you can communicate that easy, with your sensors, anybody can maybe mess up with the grippers and make a damage to the process.
This is always the risk with big data.
Yeah.
That all of a sudden everything is possible. I mean,
Yeah.
and even with your devices, you don't know who's reading your emails. I mean, so and this is something we have to take care of. And this is also a discussion we want to enforce, because it's needed. When we are looking into these devices, we have to talk about security.
Yeah, actually, since my experience in oil and gas, in the oil and gas, when it comes to flow meters and temperature, pressure sensors, there's something sort of standard. They call DLR file that's actually loaded to every sensor, and it's a standard now.
Yeah.
Still, it cannot be actually accessed that easy, but it has to be accessed with some levels of firewalls, but you can actually access that thing. And now it's becoming standard between all technology, between Honeywell, Yokogawa, those companies that are standardizing even the data file for each sensor, for each device.
Hopefully they do. Hopefully.
Yeah, so hopefully in this sort we reach that level. Yeah, because somebody actually 2 years back, actually entered the process of our oil and gas 2 years back. Maybe lots of written actually in the media about it. It becomes a crisis in the oil and gas industry. That hacker actually got to the files, and it was a disaster. So yeah, it's just an issue actually.
This will be the biggest issue, because everyone is talking about Industry of Things or Ethernet. And this is the biggest concern we also have, that how to handle these data. But this will become reality, and it's already there. You see, it's already there.
Yes.
We sell it already.
Yeah.
And I can look into each and every Volkswagen plant in the world and see the production process and the efficiency. Imagine. I can do that. I could do this from my phone right here in front of you. I will not do it because they don't like to do that. But But this is something, and other companies are more restrictive. They say, all right, like Mercedes said, no way, just keep it in the intranet.
I know.
But we have even more critical processes where we are using our devices like sensors, right? And yes, discussion must be taken, and we have to, and this is why we need each other, and we need also the big data guys to somehow to take care of this, right?
I like to add something to this discussion on security. There is no question that security is very important in the project, and what I'm seeing in the industry right now is that we're beginning to see solutions from companies, mostly on a, I guess, as we move along, we find different solutions. For instance, in the project I'm working on, we're looking into Aspera, which is an IBM company, and they have a protocol for huge data transfer called FAST, Fast System-Oriented Protocol, something like that, but to send big data. And they actually encrypt all of the data with very high level of security, extremely high. So my point is that there are some commercial solutions out there that are very secure, very secure. So we're beginning to see solutions for this security problem from all sorts of players. But what I'm not seeing actually is a standard solution. Maybe that's what you're talking about. No, maybe we won't see. Maybe the problem is too big to handle generically. We're seeing solutions for specific areas, kind of like the context aware that I was telling you, I mentioned earlier in my talk this morning. So we are seeing solutions actually that address that problem, you know, with encryption, keys, authentication, things like that.
Anyway, that was very interesting, actually, talk. I
Yeah.
like it.
Thank you very much for your attention. Any further questions? Or sorry.
Just a curious question. I think one of you two might answer is there like any possible future we might see like our microwave or like our personal device, like home devices, kind of have like NFC integrated?
Yeah.
And like if there's a malfunction, it could tell us.
I guess they will integrate. And I mean, the technology is there. This is not rocket science we do. Huh?
Yeah, like the IO link, I could tell like what part of the device is broken. You could just
Yeah.
replace it yourself or something like that.
I believe that IO-Link is a European standard, more or less, but it's also sweeping to US now. Like Control is a US company using it, and even Alan Bradley joined this IO-Link consortium. We will have this as a standard in future for these smart field devices, and I'm pretty much convinced that even in household applications we will find this, because the nice thing is that the protocol itself is standardized. So in every device we have has a digital shadow, we call it, right? So whatever's information inside is giving in a database, and this database is always the same protocol. So whatever I do, whatever function I add in there, I could give in this database, in this IO-Link database, and I connect it to Ethernet IP, Profinet, whatever. I don't care. I just need a master, and then everything is standard. And this is why it is that nice. And this is why we Germans are forcing that strongly, because at the end of the day, otherwise we end up in a mess, right? Because if each and everyone is communicating in a different language, we have an issue. Yeah.
Is this linked to any of the German VDI standards?
Yeah.
Which one? Do you know?
I don't know. I have to ask my engineers. I'm sorry. I'm head of engineering, by the way, but I cannot answer that. Yeah, it is, of course, it must be. It is, there's a P&O, a Profinet user organization, German organization, and this is directly linked to the VDI standards, so, and this is directly linked to it, but there are certain numbers behind. Yeah. And even so, I hope that Charlie Dungeon's grippers will somehow operate the same communication standards so that we can integrate your gripper in our systems. Right, Charlie?
Is Shunk a competitor or?
No, we are working with Shunk.
Okay.
Yeah, and we are cooperating with Shunk to have the same communication standard. Okay. All right. Okay, thank you very much.
Thank you.